So as the name suggests, identifying nodes is a very important part of nodal analysis. If we can't identify the nodes, we can't identify what node voltages need to be solved for, we can't write the Kirchhoff's current law equations, we can't solve for the nodal voltages. So step one really is to identify the nodes, and that's why there's an entire section in your lesson today and an example about finding the nodes. Sometimes it's pretty easy, and I think that this first example might be a case of that, but nonetheless I think it's still very beneficial to see a few examples of this. So let's look at example A. We're asked to find the nodes in this circuit. Now, remember that a node is simply a region of wires that extend all the way to the circuit elements that they're connecting. So there's one node, and I might call this, for example, V1. Now, here's one that's actually quite small. The extent of that node is quite small, but mathematically, it is every bit as valid and important as the other one. So here's V2, and then over here, notice that I'm going all the way right up to the edge of a circuit element, and there's V3, and then down here, this one will be V1. I'm sorry, V0. Now, it's not specifically shown in this case that V0 is the reference node or the ground node, but I'm still just out of tradition going to call that V0. If there were a ground symbol attached to that node, then I would know that its voltage is supposed to be 0 volts. As it stands right now, I don't know that for sure. What I can tell you is that there are 3 independent nodes in this problem. We're going to have to choose one of the nodes to be reference, and then we get to calculate the other 3. Don't think that you can have 4 equations with 4 unknowns. I made that mistake in my Circuits 1 final project, and I lost about 48 hours of programming because I didn't have a reference node. And if you don't have a reference node, your matrix will turn out to be what's called singular, which means that you can't invert it. And if you can't invert your matrix, then you can't solve the problem. So remember that you're going to have to choose one of the nodes to be a reference node. That'll just come up in the next portion of the lesson. Here, I'm going to identify the nodes. This is a bit more of a complicated circuit, but nonetheless, it is not complicated to identify where the nodes are. So I'll still call this V1. Over here, I'll call this V2. Here, this node right here, this will be V3, and then this node right here, which goes quite a long way, this would be V0. Again, most likely V0 would be taken to be the reference node or the ground node. Notice that when we've identified all of the nodes and the full extent of each node, the only things that remain are circuit elements, resistors, voltage sources, current sources, and so forth. So this is the identification of 3 nodes for that circuit. Now we get to one that I love, because this is a very challenging one. But very challenging is still not too bad, because notice that I can identify this as a node. All I have to do is go right, I actually went a little bit past the edge there, but you get the idea. So this will be V1. Now comes the tricky one. So over here, this one goes to here, but then it also goes down to here. So this is all going to be part of V2. So notice that V2 has a very unusual geometry here. Those 2 diagonal lines that are thrown in kind of mess everything up. I can choose really any node. That could have also just as equally well been called V0. There's no reference node that's identified here, so we can choose any one of these to be V0. I'll call that one V3, and then this one is going to be, I will go ahead and call this one V0, but we might find that one of the other nodes would end up being the reference node. So here we have a total of 4 nodes, 3 of which will be unknown relative to the reference node. This will lead to a set of 3x3 equations. So although it's a bit trickier than the others, notice that all you have to do is trace the full extent of all the connected wires right up to the edge of the circuit elements, and whatever that full extent is, that's considered to be one node.